Okay. Thanks, Deborah. Okay. Bill here again. So I just want to give a shout out to the company that I'm doing some work for right now, and that's 3HTI. They're headquartered out of New Jersey. Personally, I'm in Cleveland, but they are a PTC product reseller, implementer, and expert in the field. So, Windchill implementations, Creo training, whatever you need across the digital thread, as they call it. They pretty much got it covered. Gary's the owner. He's been around for a long time, and I'm sure there's a couple people in here that have maybe cross paths with him at a user group or something, or live works. But I started off at Boundary Systems, which was also a reseller that merged with PDS Vision. So that merger happened. Wow, man, that's going back officially. What is it, like 5 years ago now or something? Maybe a little bit shorter. Um, so I moved on from there. I left PDS Vision because I kind of wanted to start my own company, doing more like career coaching and stuff. But I still work for 3HTI part time. So here's their site. You can see they have all the other products listed: Creo, Codebeamer, Windchill, industries across the board, aerospace and defense, life sciences, medical, and then you can purchase Creo, and there's a resources and support page. So just wanted to give you a quick glimpse of 3HTI. Okay, the agenda today, I thought that we'd start off with some tips and tricks, even just going into the NVIDIA GPU and their NVIDIA app, because my experience is that, when, I've done anything working with a help desk in the past, sometimes, you have people that really busy working on their projects, and IT takes care of a lot of things, but sometimes there's simple things like updating your NVIDIA card that really helps your assembly or your software performance. And then there's also the assembly automatic reps and on the fly reps for opening up large assemblies. So that stuff helps out as well. And we'll take a look at that. And then we'll kind of get into the top down design with the geometry sharing. And we'll talk about the interchange assemblies a little bit, and also component interfaces here for quicker assembly of components. Okay. All right. So just quickly, there's an NVIDIA app that you can download. And if I search mine there, it actually shows up here. If I select this, let me drag this up. You can see that this window pops up and it shows a home page. My son is a gamer, so he has Steam in place. These games that you see here, they're Star Wars, Titanfall 2, and Teardown, right? So that's, my graphics card has specific settings for these games that I can adjust for the quality of the graphics, right? And then there's graphics here, there's the system, there shows my screens, and then there's driver. So this app makes sure that I'm updated to the latest and greatest driver, and it'll tell me when I'm not. So a couple days ago on the 12th, there was an update. So I basically just clicked install, and it updated it for me. And what I've found, and somebody can speak up if they don't agree. I found that the studio driver, as opposed to the gaming driver, is better for Creo. So if you do have the app, check and see if you're using the studio driver or the gaming driver. But it seems like the studio one works best for me. But yeah, one of the biggest things is just making sure that either you or your IT department is keeping up to speed on the updates for your NVIDIA card. Okay. All right. So now we'll just take a look at, this is a snowmobile that I opened up, and it took quite a bit of time to open it. It wasn't too bad. My computer's pretty beefy, but I wanted to show something that will help you with very large assemblies and being able to open those up quicker. So I'll close this out. All right. So I have my directory set here, but I'm going to go to open, and I'm going to locate, and there's a quick access. I can filter parts, drawings, and assemblies. I'm going to locate my snowmobile assembly, select it, and if I go to open, there's a drop down and there's automatic. So if I select that, it's going to open the assembly with the least amount of data that it can. So it's going to be a very lightweight rep of the assembly, basically just for visual purposes. So that was pretty quick, right? And that's because it's very lightweight, right? So if you just want somebody to be able to open up the assembly, or maybe your manager is going to walk by, or there's a coworker, you're like, hey, I want to show you my progress and just spin this thing around. This is great. Now, if you have to work on it, you can actually retrieve all the data that's associated to the parts that you can work on it. So I can select this, for example, and then there's a retrieve icon in the mini toolbar here. And then when I do that, that gives me access now to all the features and stuff of the part so I can work on it. Okay. I also want to show this. So I'm going to open up the assembly again. And a lot of people don't know that you can say, for example, you only have to open up a specific subassembly of a larger assembly or something, right? And you want to not have to wait for your large assembly to open. What you can do is you can go to find your main assembly again, your top level assembly, go to open, and then there's open representation. If I click that, I can either select a rep that I previously created, or I can define a new one on the fly here. So I can select this button like that, and I can give it a name. And then from here, I can say, hey, I just want to open up the chassis, or I just want to open up the engine and the chassis. So those two assemblies, right? So of course I could have named this rep, chassis and engine. It would have made more sense. But now on the fly, I can click open, and it's just going to open up, that rep, and you can see it here in your manager, in the view manager, that I have that test rep here. Okay. So it's just a couple, what I would consider tips and tricks here. Okay. Now I'm going to close this out. All right. So now let's go to a different assembly. All right. So, or actually, let me move to this slide. So now we're going to talk a little bit about top-down design and concurrent engineering and designing. So, a lot of companies use a bottom-up approach, and sometimes it depends on how experienced the engineering team is. How large or small the team is. If you have few guys that are really experienced and the products aren't extremely complex, a bottom-up design approach may be just what you need. And incorporating a top-down design process may just convolute things and just add complexity that you don't need. But if you're working with large assemblies and there's data sharing, and you want to streamline your assembly process and have people working like concurrently on the assembly without problems, then incorporating a skeleton part for the top-down design process is good. So to start off with, there would be to incorporate the top-down design process, it would fall on the lead integrator slash designer, or the engineering manager, or the head engineer, and they would come up with a plan as far as what to include at the top level in the skeleton model to drive changes throughout the assembly, or to propagate changes. So for example, maybe Tim is the lead engineer on a project. He's going to create a skeleton part that consists of maybe datums plus sketches, surfaces, whatever he feels like is needed to create the structure, the foundation of the assembly, so that if he so if anybody changes the data in the skeleton part, all the changes propagate seamlessly without any errors throughout the assembly. So this is a sketch for the Husky Razor that we're going to look at. and this is what he came up with here. And then there's an engineer, another engineer, and you can see that um, he's developed this skeleton sketch of the razor, and all these different engineers, right, are sharing that data into their subassemblies or parts, right? So these blue lines are the sketches of the skeleton part, and they've shared those in, and they've created an association between the solid geometry and those sketches, so that if the sketch in the skeleton part is updated, those changes propagate to these components and they update without any problems, which is pretty powerful. At the skeleton part at the top level of the assembly, you could add solid geometry as well to the skeleton. And the good thing is that whatever you add to the skeleton will not add weight to your assembly. And also you can exclude that from your BOM as well, that skeleton part. Okay, so here's the actual razor assembly and the Husky razor skeleton part. You can create the skeleton part from the create button in the component group in the ribbon. So there's part and then there's skeleton model. You would just select this node and give it a name. We already have that, and you can see here that there's different sketches that are named that drive the assembly. So there's top profile and highlights in green here, right, in the window, top offset, bottom profile, and we can go into some of these. There's the pin. So if I go into my edit here, you can see that, these pins are created here in this sketch. We can move these things around. And then there's these published geometry features. So after you've defined the um, data that you need in the skeleton part, whether they're a combination of sketches, ad- additional datums to the default datums, surfaces, or whatever. If you want to make it easy to share that geometry or data into parts, you would create a published geometry part. So for example, I would go to model intent, or um, where's my, go into my part here, model intent, publish geometry. So the published geometry lets me collect surfaces, bodies, chains or curves, and references, right? Like datum planes and coordinate systems, axes. So I can collect all four of those types here, right? And then once I do that, if I want to share that geometry into a part, it's very easy. I can go into my component, activate it, and you can actually see they already have four of the external copy geometries, which are actually the published geometries from the skeleton part. And to do that, all I have to do is create a copy geometry feature, and you can see it automatically enables the published geometry in the content group. And if I want to share any of the published geometry from the skeleton into this component, all I have to do is just select it here. Okay. Now that's all has already been done, so I'm not going to do that. Now, if you didn't create a published geometry feature to share geometry, that's okay. You can still share geometry from your skeleton part. You would just have to deselect the published geometry button. And then from here, you would go in here and select the surfaces, bodies, curves, or datum planes, for example, that you would need. Okay. So if I select each one of these, there's a top profile curve, and then there's that curve, and there's a location for the pins, right? So all this stuff is shared here. Now I want to show you the power of this, right? So obviously this takes more time up front. The bottom up approach is, different people, different engineers are working on their assemblies or their parts. Then at some point they have to assemble all those together. But the problem with that is that if you have to make changes, a lot of times, those relationships, those constraints will blow up in the assembly. But if you spend a lot more time up front, planning out your skeleton part and what needs to be in it to efficiently and quickly drive changes throughout your assembly, it makes that time you spend up front worth it, right? So just to show you this, I'm going to take the top profile curve, and I'm actually going to go into my sketch and kind of show you how this is laid out, right? So if I want to, I can change this angle from 49, right? I can say, hey, let's make that 50 or something. Exit out of that. I can change this bottom profile curve as well. This is actually a spline. I want to grab this one. I can change that spline and move that out. I can change this angle, right? I can make that 42, right? Then if I regenerate this, right, all the components that are associated to those curves also update. So you can see there's no errors or anything. I can also change the locations of the pins. Maybe I'll move this in a little bit. Moved it over. Regenerate. That moved over just fine, right? So this is very powerful. And like I said, a lot of people, when they talk about skeleton models and top-down design, they have a lot of questions and they're kind of leery about incorporating it into their design process. Actually, that makes sense because I think that subconsciously engineers know that there's a lot more time that needs to be spent up front to develop this, but it's well worth it. There's also a functionality
Bill,
called.
Bill, I don't mean to, sorry for interrupting. There's a question in the chat asking
Oh, is there? Okay.
why reference a published geometry instead of the sketch directly?
Yeah. So published geometry is used primarily for readability. So when you create your skeleton part, you want to create this in a way that makes sense. So say for example, there's a design engineer or a lead engineer that develops a skeleton part, but they leave the company or something, or they get moved off the project and somebody else has to take the project lead. People have to know, whoever's in charge for developing this assembly needs to know how this skeleton part was created, why the elements of it were added, right? How it was structured. So if I create these published geometry features, I can actually name them, right? I can rename this if I wanted to, right? So I want to be able to know what I'm sharing and where it's shared to. So ideally, I can rename this, and I can, even rename this, for example, right? So that whoever I hand this off to, whoever is involved with this assembly, can look at the skeleton part, look at the external copy geometry features and the components, and know exactly how it was created, why it was created, and where that geometry is shared. If that makes sense. And it's a lot easier, right? It's a lot easier to select the published geometry feature, right, than it is to select all the features in the skeleton that you want to share. Like I'd rather, if I'm like, hey, you know what, this mechanism right here needs, this top curve, this bottom curve, and this front curve here, and maybe a coordinate system or a datum plane, right? If that mechanism part needs that stuff, I'd rather have it contain all in one published geometry feature, right? Because it's easier, it's a lot cleaner, and it's a lot more efficient to do it that way. I hope that answers your question.
Partially, but thank you.
Okay. Well, I mean, you're free to ask me anything else you'd like to ask. Maybe I
Well,
didn't.
yeah, you named. I don't want to derail the meeting, but you named the sketches as well, right? So it seems like you're doubling the features in your skeleton. For I don't really see the game, because if I know the whole history or design intent could be well documented by naming, as you did, the sketches. I understand you can rename the published geometries, but if you already do that with the sketches, features are already identified clearly, right?
Yeah, you're correct. But going back to the point that I made about published geometries being able to contain multiple elements of the skeleton, such as surfaces, datums, sketches, right? If you do have to,
I see.
in this case, because the assembly doesn't really have sub-assemblies, they're just components.
Right.
Yeah, you're right. You could just, do a copy geom feature, and these skeleton or these sketch features are already named, so you don't really need the published geometry feature. But the published geometry features really come into play when you want to grab a whole bunch of data to
And
copy into a
consolidate
part
it in one single
and
feature.
consolidate it. Yep.
Got it. Okay, thank you. That
Yep.
makes more
You're
sense
welcome.
now. Thank you.
Sure. Okay. So now let's also take a look at these notebooks. So this is a blade layout. So whoever developed the skeleton model also may want to control who has access to certain dimensions, right? So there may be some dimensions that need to be controlled at the top level that nobody should have the ability to change but that person. And notebooks are a great way to do that. So this is a notebook of the blade, and you can see that, I've created these parameters in here. So basically you create parameters, which are the dimensions, and then here's the repeat region table here. And this is very easy to create. All I did was basically create a drawing from the blade here, and then export a DXF of that drawing. And then I went to my layout. The layout's here. There's new notebook. You can create it there. And then once you have that, you can import your DXF file very easily. Okay. And then once you create this layout, you can drive the dimensions in your assembly with the layout. So if I go back to my assembly and I open up this razor, and let me grab these dimensions. All right. If I double click this 47.5 dimension here for the angle of the blade, right, you can see that I get a message in my status bar down here saying that the blade is driven by relation D1, blade underscore angle 02, right? So basically what it's saying is you don't have the authority to modify this dimension because it's controlled by the notebook that it's associated to. Okay. And if I go into my relations, you can see that these parameters are the same parameters that you would find in the notebooks. If I go back to the blade layout, there's my parameters. They're also here as well. Okay. So this can get as complex as you want. You can see you can create a layout for your skeleton too, your latch. It's really up to you to determine, how to create this and what's the best way to create it for your specific product. Okay. I also want to show, I do a lot of surfacing work, so I want to kind of show how that's integrated with top-down design as well. So let me go to this. Okay. So this is a fighter jet concept that I created. And you can see, I can walk you through it. There's a landing gear assembly that I was working on, and there's the, retracted, there's the extended version of the assembly, there's the different turns, right? So, but the reason why I'm showing you this is that this is a concept, right? This is an aircraft concept, and it's still being driven kind of through the skeleton part, right? Now, this was originally designed in Freestyle. So if any of you have seen that, Freestyle is a subdivision sculpting tool that lets you model almost like you're sculpting with clay. So what I did was I created this concept, and then I shared that data, that geometry, into this skeleton part, right? And then I also cut out from that data, this quilt and the skeleton part, the door for the landing gear. All right, and you can see, you know, I've got my surfaces here. I have my external copy geom feature coming from the original part where I designed the aircraft, you know, and then if I go into my assemblies, there's a copy geometry feature here. You know, there's also one right here for the door, right? So you can trace this, all this data, you know, you can trace back to the original part that I can open up and then show you where this was created. So that's going to be right here. So here's the original aircraft. Here's the freestyle mesh that was created, right? So if you follow the, you know, trail here, you know, it all started with this. I created this. I created a published geometry feature that we just talked about, and that feature contains these different quills. So there's the overall, you know, mesh, and then there's the canopy, and then there's the venting here. All that stuff was created as a published geometry feature, and then that was brought in to this skeleton part right here. And then once I create my skeleton part with all the different datums and stuff that I needed for the landing gear, I then shared that geometry to these different assemblies for the landing gear. Okay. I guess I'll just pause there if anybody has questions.
Bill, I've got one question. So, are we using the AAX now? And is it a separate license that costs more?
Yeah, so this skeleton part is accessed through the Advanced Assembly extension, and it does cost more.
Is it typical that people working at bigger companies have it, or is it kind of bundled? I'm just wondering.
Yeah, so you can buy the extension separately or it's bundled. I believe it's included in like the tier 3 package because there's Creo Design Essentials, there's Creo Design Advanced, and I think then there's Advanced Plus. So I'd have to check to see if it's included in the Advanced, which is the tier 2, but I know it's probably included within the tier 3. Yeah, companies working in aerospace and medical devices and automotive, they're definitely using the Advanced Assembly extension. If they're not, it's got to be very challenging for them. But
Okay, good, thanks.
sure, no problem. Okay, let me just make sure. Let me get back here a second. Okay. One of the things that's nice too about the Advanced Assembly extension is the ability to swap out components. So there's an interchange assembly feature that we'll look at now. And we're looking at this on a smaller scale with this blade. But if you just use your imagination, it's not hard to see how it can apply to, you know, a larger assembly. Maybe it's an engine that you want to swap out. Maybe it's a different transmission for a vehicle, braking system or whatever. But the you know, concept, you know, is the same. So what I've done is I've created 3 different blades. You know, I've changed the angle on the blade, for example, in a few of them, and some different things. So once you create the variations of your part or your assembly, you can go to the assembly node, and then there's an interchange assembly option right here. And you can give this a name like blade interchange, and then click OK. And then what you're going to do is you're going to bring in the variations of your part or assembly. So in my case, I'd bring in the different variations of my blade, which are blade 1, 2, and 3. Okay, I might move this one over. And then what I'm going to do here is define the references on the blade that I use to assemble, right? So for example, I'd go to the reference tag collector, and I say, hey, this top surface will be a reference for constraining on all the blades, and then this front surface, as well as this angled right surface, okay? So you can see that's going to show up here in the footer. There's the references for constraining. And once you have those tags created, and then there's the reference pairing table, okay? Now, if you already have an assembly, which I do, where the constraints on the blade are defined, you can bring in the assembly. So I can find that Husky razor knife assembly. And as long as I add these two components that I'm pairing it with, it'll automatically find the references in this first blade and apply them to the second and third, right? But I want to show you the other way too. So here's the tags, the tag column, same tags that are here in the footer and the model tree. So now I need to select the active component, which is this one. Then my components to pair, which are these two. Then I click evaluate. Evaluation rules. You can see that, they now are going to share, every one of these blades is going to share the tags that were created. And there's a component interfaces, there's this, inheriting the same parameters, history, all that stuff, right? So I've already done this, and I've created one. I'm going to erase. So what's cool now is that if I go back to the razor assembly, I can swap out, that component, or if it was an assembly, for another. So I can grab this blade right here, the blade latch, and I can do a replace. And then if I choose then there's an interchange node right here. And if I select that, I can click on open, and then this shows me the different versions. So there's an interchange 3, blade 2, and blade 3. So I can select either one of these, click OK, apply, click OK. And now it just seamlessly swapped out the original blade for the second version. So you can imagine how powerful this would be, right? For swapping out different components and assemblies, because you might have a different version of a vehicle or the product, right, that you're creating, and you want to be able to show those options. Any questions? Okay. So the next thing I want to talk about are the component interfaces. Let me just make sure. Let me pull this up and move it to the side here a second. Okay. So I just opened up this pin right here. And up in the ribbon here to the right, there's the model intent group. And if I select that, you can see that there's an interface 001 that I can create. And in here, what I'm going to do is define the references on this pin, so that when I assemble it to the razor, I don't have to define these surfaces when I constrain it, only the surfaces that they constrain to in the assembly, right? So it saves time. It saves me basically two clicks, right? Because I'm going to define this cylindrical surface in the bottom of the head here, this flat surface. So I would create a new constraint here. I would give it a name. I'll say placing, for example. Automatic. I could say, hey, let's make this a coincident constraint for that surface, and then a coincident constraint for that flat surface, right? That when I do that, it creates this footer down here with the interfaces. The power of that is if I just hide that pin, when I want to assemble the pin, I'll just look for it here. Right? You can see that when I assemble it in, I've already defined the two constraints, or the two surfaces I'm going to use to constrain, previously through the component interface. So all I have to do is select this surface and that surface to mate that component. So that's another little thing that really makes, assembling a lot faster within Creo. Okay, so far we've covered some large assembly tips and tricks, talking about the NVIDIA driver and the updates with that, and checking on that. We've talked about assembling the automatic rep option so that we can open up these large assemblies a lot quicker. And if we need to, we can retrieve the component data. We've talked about creating an on the fly simplified rep. We've talked about data sharing and skeleton models and notebooks. Now, one thing I also want to talk about are the associative shrink wraps. Okay. So what's great about the advanced assembly extension is that I can create a lightweight shrink wrap, for example, of this assembly that can be shared with anyone. And the great thing is it's lightweight, it's easy to share. The person I share it with can't modify the data, which is good. So if there's a new engineer that was just hired, or somebody with less experience, and they need data from this assembly to use or to visualize, but you don't want them to be able to modify the assembly, you can create a shrink wrap and share it with them. And the great thing is that whenever you update the assembly here, so say I make changes to the skeleton part and the shape of this assembly updates, because the shrink wrap is associative and it has these extra copy geometry features, the shrink wrap will update. So for example, we'll create a new part here and we'll call this razor associative shrink right there. Okay. And we'll go to the copy geometry feature, or the shrink wrap feature, sorry. And what I'll do is I'll open up my razor assembly right here. Okay. And I can grab the outer shell surfaces. I can do a manual selection. There's an auto collect solid geometry. I'm going to use that option. And it says, would you like to exclude internal components? In this case, I don't. I want to keep them. I'll say yes. And then if I go to the options tab, there's now an option for bodies, which is great. So now I not only have the ability to create a quilt shrink wrap, but I can actually create a shrink wrap that contains the individual bodies of the assembly. So I'll select that. I can merge all the bodies together, or I can keep the bodies as separate objects. I'm gonna keep them separate. And I'll click OK. All right, so now there's my shrink wrap part. It's more lightweight, doesn't contain all the features of the assembly. Then there's the individual external copy geometry features, and we have a list as well of the 21 bodies. So that's a new associative shrink wrap feature, is this new bodies shrink wrap. And then of course, right, we have all this associativity. So if I go back to the razor and let me grab this one from here again, bottom profile. If I modify this and bring this back up a little bit, and maybe change the angle here, then regenerate. If I switch back now to the shrink wrap and I regenerate here, you can see updates with those changes. Pretty powerful. Okay, I'll just pause here again. Any questions?
Bill, I'm just trying to remember through memory on the steps he took to get that separated body shrink wrap. I got down,
Yeah.
create a new part, make a shrink wrap, copy geometry, select the assembly you want to bring in, and then from there it's little plus options. Okay.
Yeah. So I went to the collection method, and I changed that to the auto collect all solid geometry.
Okay.
And then after that, like you said, I went to options and I just selected the bodies node. You're probably trying it on your end, huh?
No, I'm trying to write down. I'll try it later.
Oh, you're writing it down? Okay.
And remember, if everything goes okay, this should be recorded and you can look back at the recording on YouTube. Hopefully that'll work.
Yeah, we got a lot of like base machines with fixtures that go inside of them. But if you shrink wrap a machine with a safety surround on it and everything, you can't see inside of it very well. But if you separate the bodies, you can hide the surround, you can hide other things to see things while keeping it light. I like that.
Exactly. Exactly. And then let me also show something really quick here. This is going to be kind of rough, but I think it's worth talking about. Just create something really quick. All right. Just place a hole here a second. You just add some rounds. I probably should just add a couple more. Oop. Okay. All right. So there's also the merge and inheritance feature, and you guys have probably heard about this a little bit. If maybe it was a while ago, and this is a refresher. But say for example, and I should press this all the way through. One moment. So say for example, you're creating like a casted part or something, and you need to share this data with the machine shop, right? Well, it's cool because with the merge inheritance feature, you can share a component like this, right? So that whoever's on the shop floor that has to make adjustments to it so that it can be manufactured correctly, they can make changes to the model that won't change the original model, right? So for example, this is part 002. I'm going to create a new part here. 003. I'm going to go to my get data, merge inheritance. And then what I'm going to do is I'm going to go to open and I'm going to find the 002 part, click on open, default constraint. We'll just do that. Add bodies. There's my merge feature. And I'll click OK. So as you can see, I handed this off to a guy in machining, maybe, he's like, hey, you know what, I need to make some changes to this. So now he has this component, right? But he doesn't have access to all the features in the model tree that the engineer has, right? But what's nice is that his component will update because it's kind of external bodies. So you can see there, there's a reference model. If I say open the reference model, it opens up the original one, right? So now if I come back in here and I edit this from 0.75 to 0.5, and I go back to this version, I can regenerate, and now you can see that hole is updated with the new size, So that's real nice, right? You can define like the main dimensions in here for this component, right? But you're the only one that can say, hey, I'm changing the design intent of the component, right? But he still has the ability to chamfer this off, or he can add more holes here if needed. He can say, hey, we actually need like a hole here, here, and here. He still has the model, the solid geometry to modify, but he can't modify the original dimensions like you have. Now there's a different version. If I go back into the inheritance feature, there's merge and there's merge and inheritance. If I select the inheritance and then click OK, this version has all of these features from the original, right? And then if you make any changes, so if I change the round, for example, here from, it says, please confirm adding this dimension to the inherited variable datum table. We'll say yes. I'll change that to 0.3 or something. That's way too big. Let's do 0.2. All right. So now there's a variable items table that's going to be here, varied items, and you can see that I just added a new value there. Okay. And then I can say save source model. So whatever changes I make to this, so say you hand this off to, maybe the guy, the machining is really experienced in CAD as well. Maybe he has Creo knowledge, and he just was like, hey, I'm tired of working on the computer. I just want to do the machining I used to do. So now he's back there. But so he has good like Creo knowledge. You trust him. So you give him the ability to use this inheritance feature with the features. You say, hey, you know what? These are the rounds that I added. If they should be smaller or larger, or the hole should be larger or smaller, I trust you to make that change. Now he can, and then he can say save source model, and then give it a name, for example. Click OK, right? And now there's a new version, right? So what do you guys think of this? Are you using this already, or do you think it's something that you could use in the future?
I personally think it's kind of dangerous it opens a kind of worms in terms of model and version control. Because, if someone creates a model and then publishes the inheritance, or the model in a certain configuration, I think that person should be the one in charge. But that's me. The person should be in charge of controlling its feature, and not giving anyone else the ability to modify things, because otherwise machining can say, well, I fabricated it to this, but the original model was that. So version control seems kind of critical here. Because you rightly said, if you trust a person, which is good from a human point of view, I don't know.
Yeah, no,
Yeah,
from a version control perspective, the water is murky. No, I totally get it.
So this
I
might
can really see
work in
this
a small environment.
a
But
smaller environment.
it's a powerful way to incorporate changes. I would be careful about who makes what changes and when, and how that is controlled.
Right. Yeah, it should have a use with caution, right, in the feature somewhere, like a warning symbol, a caution symbol. Yep, I would agree with that. Okay, well that takes me to the end of what I wanted to present today. I hope that you guys found value in this and maybe learned a couple of things. But yeah, if you have any questions, feel free to ask now.
Bill, maybe go back to your slide about the company in case somebody wants to contact your company.
I have one more comment, I think, or suggestion. With the automatic rep and making the reps on the fly when you open, there's a config option where it never asks you what rep you want to open when you open things. Sometimes
Oh.
that's deselected by default. And then there's also a config that you can always open the default rep. And that would also kind of bypass that step too.
I gotcha. Great. So it'll be in here somewhere.
Trying to find it myself here. Open simplified rep by default.
Okay, great.
And
There it is. Retrieves a model and specified rep. Yes, use open rep dialog. No, retrieves a default rep, which the master rep unless defined otherwise. Specify name, retrieve the specified rep when it exists. If not, the default rep. Oh, great. Thank you for sharing that.
So you could always name a rep like simple. And then if you ever make a simple rep, it opens that. Or,
Right.
You saw the description. So it gives you a lot of
Yeah.
automatic control if you want to do things the same way.
No, that's great. Thanks for sharing, Zach. Appreciate it. Yeah, so let me bring this over here a second. You guys can contact me. There's my email. I love to have conversations around Creo. I like helping people. You guys are all experienced, but I know that many times people are just so consumed with the kind of work that they do, and they're so busy that although they have a lot of knowledge, they don't really have time to break away and kind of learn what's new in Creo or incorporate a new process or something. So if you ever need help with that, definitely reach out to me by email. I saw that we also have Lucas on here from 3HTI. He's a very bright guy, and he's great with CodeBeamer. So Lucas, I'm not sure if you want to just say hi for a second, but
yeah. Hi, everyone. Can you hear me okay?
Yes.
Sorry, I wasn't expecting to speak. I have you coming through speakers. I come through the microphone here on my webcam. But yeah, thanks, Bill. I work at 3HTI as well with Bill. I've been with them about 7 months now as a solutions consultant. I primarily work in the Windchill and CodeBeamer spaces, but I'm always looking to learn and trying to brush up on my CAD skills and Creo skills. So thanks, Bill.
no problem. Thanks, Lucas. We have a GD&T workshop coming up next week.
So we're starting to run out of time here. I could send the email list of people on this call if you guys wanted to send out something about the GD&T. So that would be your event, not a Badgerland event.
Okay, well, thanks a lot for coming on, guys. Looks like we made pretty good use of our time. Feel free to reach out to me and had a lot of fun with you guys. So thanks.